Hey everyone, and welcome. If you're using Python, you're no doubt familiar with lists. But what about their close cousin, the tuple? Well, today we're going to pull back the curtain on this simple yet seriously powerful data structure. Let's jump right in. So let me kick things off with a question for you. Have you ever been writing some code and just thought, man, I need a collection of items, kind of like a list, but I have to be absolutely sure that it never ever changes by accident? Well, that exact situation is why tuples exist. So what is a tuple?
At its heart, it's an ordered collection of items that is completely unchangeable, or what we call immutable. And honestly, this slide says it all. If a list is like a shopping list on a whiteboard, you can add stuff, erase stuff. A tuple is that same list permanently carved into a stone tablet. It is not going anywhere.
Okay, to really wrap our heads around this, we need to look at its fundamental building blocks. So let's break down the 4 key properties that define what a tuple really is. First off, you're almost always going to see them wrapped in parentheses. Second, they're ordered, which just means that items stay in the exact sequence you put them in. Third, and this is the big one, the main event, they are immutable. Once created, they're locked in. And finally, they're totally cool with duplicates, so you can have the same value show up more than once. So with those properties in mind, it brings us to the most important comparison you can possibly make. What is the actual difference between a tuple and a list? I promise, once you get this, everything else just clicks into place. And here it is, plain and simple. The one single defining difference is mutability. A list is mutable. It's flexible. You can change it, add to it, take things away. A tuple is immutable. You can't. That whiteboard versus stone analogy, that's the perfect way to burn this into your brain. One is flexible, the other is forever. Let's see this in action, right? Here, we've got a normal list with the numbers 1, 2, and 3. Then we just target that first element at index 0 and swap it out for 99. And it works. No problem at all. The list updates, code runs smoothly. Now let's try the exact same move with a tuple. We create it with 1, 2, and 3. We try to change that first element to 99, and bam, we hit a brick wall, a type error. Python literally stops us and says, nope, you can't do that. A tuple object does not support item assignment. This error is the tuple's built-in security guard enforcing that carved-in-stone rule. All right, so we know what they are and why they're so different from lists. Now, let's get our hands dirty. How do you actually make them and use them in your code? It's time to open up the tuple toolkit. Making a tuple is actually super easy. The most common way is to just put your items in parentheses. But get this, Python is smart enough that if you just separate items with commas, it knows you mean to create a tuple. You can also use the tuple function to convert something else, like a string into a tuple of all its individual characters. Pretty handy. Okay, pop quiz time. Real quick, take a look at this on the screen. 4. Is that a tuple? What do you think? And the answer is nope. This is a classic Python gotcha. Because parentheses are also used for math, Python just sees the number 4 inside. So here's the crucial trick. To make a tuple with just one item, you have to add a comma right after it. That lonely little comma is the signal that tells Python, hey, I'm making a tuple here. Now, when it comes to getting stuff out of a tuple, it's going to feel really familiar. Just like lists, tuples use zero-based indexing. You can count from the front starting at 0, or you can use negative numbers to count backwards from the end, where -1 is always the very last item. So this means accessing elements works just like you'd expect. T0 nabs you the first element, P. T-1 gets you the last one, N. And you can also slice a tuple to get a chunk of items. For instance, T03 gives us a brand new tuple with the elements from index 0 up to but not including index 3. And listen, just because you can't change a tuple doesn't mean you can't ask it questions. A ton of built-in functions work perfectly. You can ask for its len to get the size, find the max and min values, or use methods like count to see how many times something appears, and index to find out where it is. Okay. Basics are down. You ready to level up? Let's look at some of the more advanced, really powerful ways you can use tuples. These are the techniques that show you why they're so useful in the real world. So what happens if you really need to sort a tuple? Well, you can't do it directly because it's immutable, but there's a super common and clever workaround. You just convert the tuple into a temporary list, use the list's own sort method, and then, you guessed it, convert that sorted list right back into a new tuple. It's a clean 3-step dance. Oh, you're gonna love this. The zip function is just fantastic, and it almost always works with tuples. What it does is take two or more collections and it zips them together. It creates a series of tuples, pairing up the first items, the second items, and so on. It's so clean and elegant. And if zip puts things together, then zip with a star, zip star, takes them apart. It's the perfect inverse, like a magic unzip button. If you have a list of tuples, zip star can unpack it back into separate tuples. You can see here how it takes a list of laptop and price pairs and neatly splits them into a tuple of all the laptops and a separate tuple of all the prizes. So useful.
Okay, so after all that, let's bring it all home. Why should you even care about tuples? What is the big takeaway for you, the programmer? Here's the bottom line. First, data integrity. The fact that they're unchangeable is a feature, not a limitation. It protects your data from being changed by mistake. Second, there can be some slight performance wins. Third, they make your code way more predictable. When you or a teammate sees a tuple, you have an ironclad guarantee that its contents are fixed. And finally, they have a superpower. Because they're immutable, you can use them as keys in a dictionary, something a list can never do.
So I'll leave you with this thought. Now that you understand the unique power of Python's unchangeable list, where are you going to use it in your next project? Thanks for tuning in, and happy coding!